Hello, today I will be explaining how to perform a polymerase chain reaction or PCR experiment. The reason to perform an experiment like this would be if you want to amplify the DNA in your sample. So you would begin by designing your primers. These primers need to be about 20 nucleotides in length, and they need to have a 40 to 60% GC content so that way it binds better to the DNA template. And the melting temperature needs to be about 52 to 58 degrees Celsius. So once you have your primers designed, you are going to grab a 0.2 milliliter PCR tube and prepare your mixture. So in your mixture, you're going to have a template DNA, which will be at 200 picograms per microliter. You're going to have your forward and your reverse primer and magnesium dichloride at 0.1 to 0.5 millimolar in concentration, your DNTPs, which will be at 200 micromolar in concentration, your Taq polymerase, which will be at 0.05 units per microliter, the buffer at 1x concentration, and finally H2O. The water is going to add enough so that your total volume will be 50 microliters in the PCR tube. You will use a pipette to mix your solution, so you'll pipe that up and down, and then you'll put the tube in the PCR machine. Now the way the PCR machine works is it begins by increasing the temperature to 90 degrees Celsius so that the hydrogen bonds in the DNA double strand will break. That way you'll have two single strands. Then it will decrease the temperature to 45 to 65 degrees Celsius so that the primers can now bind to your DNA template. Then it's going to increase the temperature again to about 72 degrees Celsius so that Taq polymerase can bind to your primer and your DNA template and start replicating the DNA. At the end of the cycle, you're going to have two double strands DNA. So after about 25 cycles, you're going to have a much higher concentration of DNA in your sample.